Warning: this low-budget experiment may cause some dizziness. This video is about an old challenge. You can find the link in the descriptions below. These gentlemen used a rope and some laser beams to align the rotating Earth to the North Star and to simulate the North Star trails. It took quite some time to align the experiment. I have a different approach, easy for you to understand and to replicate or verify. If you rotate an object, it doesn't matter what kind of object it is, or liquid or air, it doesn't matter. If it rotates, you can pinpoint a center. As I'm demonstrating here, every rotating object, you can accurately pinpoint the center. This is the basis for my experiment. I set up a tripod and mount a camera on top of the rotational point, aiming at the ceiling to pinpoint the center and use this as the North Star. I use a red magnet as a reference point, so it's easier for me to find the center. Okay, let's rotate the tripod and see if you can find the center. This is approximately the center. It's easier to spot with a higher revolution. I'll speed up the film and move my magnet to the center. This will be Polaris, which is the same as the tripod's rotational point. No need for laser, which is in this case the whole ceiling rotating around Polaris. I hope you're not getting dizzy. But what if we change the angle of the camera? I tilt the camera higher so Polaris will appear lower on the screen. Let's spin the Earth and see what happens. This is still a perfect representation of the spinning globe and the star trails around Polaris. Let's move the camera to the right so Polaris will appear on the left screen, and rotate the Earth and see what happens. This is again a beautiful representation of the spinning globe and the star trails around Polaris. Let's aim the camera back to Polaris, which is the Earth rotational point, aiming at Polaris. As you can see, the camera is aiming at Polaris again, and you can see the perfect star trails around Polaris. But what if the Earth is rotating around the Sun and moves with great speed through the galaxy? Let's move the Earth and see what happens. We lost Polaris. It doesn't matter if I aim the camera at Polaris, Polaris is gone. We lost it. If the Earth travels around the Sun or through the galaxies with millions of miles per hour, Polaris is gone. The Earth rotational point is pointing at some other stars or space. What? Polaris is so far away we won't notice a difference? Yep, we will. Or the Earth is hanging on a rope connected to Polaris. The second part of this experiment is Polaris and the star trails around Polaris on a stationary flat plane. The stars are always rotating around Polaris. For centuries, it doesn't matter the angle of the camera, the stars are always rotating around Polaris. If you move away from Polaris, it will appear lower on the horizon. If you move towards Polaris, it will appear higher above the horizon. The stars are always rotating around Polaris above this beautiful stationary flat plane.